Hello from Vienna. My name is Tarik Zukic and I have spent 25 years in the hearing aid industry. This is a long time and many technological change happened since the mid-90s. Some technologies from my early career are obsolete today, but there are some things related to development of a hearing aid that stay the same. For some of those basic concepts about a hearing aid product, it took me quite a long time to see and understand, much longer than to acquire a new technology or a skill. My today's talk will therefore not be addressing any particular technological aspect of the hearing aid, not any recent market challenge or audiology research, but it will describe a very general feeling about what makes a good hearing aid good. For the title, I have chosen the word Masterclass, which can mean giving advice, sharing experience, rather than explaining a process or providing facts. It can actually mean anything. I have also added a buzzword, OTC, meaning over-the-counter distribution of a hearing aid product that describes a change in the US in the regulations of a hearing aid as a medical device. This change in a product description is a rare opportunity for changing the paradigm of a hearing aid product. It is so useful to see the old concept in a new light. OTC is also a rare opportunity for newcomers to enter this extremely closed industry. My talk will be coming back to this opportunity again and again to compare it with the traditional picture of the hearing aid product. Before I begin, I want to thank Beijing Society of Audiology for inviting me to this forum. It is an honor and pleasure. I will begin with a story that probably have happened in 1997, just after I started working at Vienna Tone, which was a traditional hearing aid maker and a part of the ReSound Corporation. One day, a guy from the repair department came to my desk carrying a hearing aid and asked me if I can fix it. The customers were complaining about the sound and many devices were returned, such as this gray device I now had on my table. I have told him that I will try and asked him what the customers are complaining about. He said that the device sounds poisonous. This description did not help me much. I have opened the device and saw quite a simple PCB comprising of few transistors and other discrete components. The device was fully analog. My engineering degree was in digital signal processing, and the challenge of tweaking the resistor values on the schematics in order to make the device sound less poisonous seemed for me the most impossible task imaginable, which in the end it indeed was. I was not able to fix the product, not even to try fixing it. The important thing in this story is the description my colleague gave me. What was the meaning of poisonous sound? And how this relates to the electronic components inside of the device. As a young engineer, I believed that the technology is driving the products into the future and that the technology is driven by the research. So if I read the newest papers from IEEE proceedings and build this knowledge into the product, this will predictably lead to better products and benefit for both company and customers. This was a mistake. Why is hearing aid made of two words? The word hearing and the word aid. Sometimes it is very helpful to remember the linguistic origin of common concept. In the concept of a hearing aid, the first word describes the problem and the second word, the solution. There is no solution without a problem, we all know, but still I have sometimes the feeling that the solution becomes a thing in itself, detached from the problem and self-confident to the extreme. In the case of hearing aid development, it is important not to forget that the value of the product is determined by the benefit to the particular user, not by the amount of technological excellence that was invested into the development. Those two things do not always correlate. In other words, engineers tend often to think about the product as their baby and forget that the real owner of the product should be the customer. Which leads me to another unlikely question. Who is actually the customer in the hearing aid market? This diagram shows a very simplified ecosystem of a hearing aid product with manufacturer, distributor, the payer of reimbursement and the patient. It is important to note that the patient is sometimes not paying for her device and very often not deciding about which product to purchase. That means that in this ecosystem there are many customer relationships. The distributor is the customer of the manufacturer, and reimbursement insurance is the customer of the distributor. The patient is rather the customer of the insurance than a customer of a manufacturer. When designing a hearing aid product, it is important to know on what customer to focus. Above all those relationships, there is a regulation body that decides what kind of product will be legally allowed. This body is in a relationship with manufacturer and distributor, and they all try to influence each other. Those relationships are sometimes very intense. Why? This can be seen in the following diagram. The value chain of the hearing aid product might be surprising for someone. It is important to notice that not only the price of the product, but also the benefit, the real value of the product, increases along this axis. The contribution of particular stages in this chain is, however, very interesting. In this diagram is the explanation behind the rationale of the strategic development of the hearing aid industry in the last 20 years. In the first decade of the century, a consolidation swept through the industry. The mergers and acquisitions secured market share by integrating smaller competitors. By 2010, there were only a few big hearing aid manufacturers left. Medium-sized players such as Sonic Innovation, Unitron, and Intertone have been all integrated into bigger systems. Smallest players survived only if they have found cover in a geographical niche. This step made sense since the medium-sized companies were not able to carry the increased R&D load of digital technology. There is a rule of thumb that for a company to make its own product, it is necessary to sell more than 100,000 units every year. Next, there was a horizontal integration. Cochlear implant companies have been targeted, AB, Neuralec, or a venture into bone conducting was staged internally as in Oticon Medical, a step that optimized leveraging R&D costs. It is not clear if this step was successful, as the next step was. The hearing aid manufacturers started acquiring distribution channels, AudioNova, Audica, amassing so practically the whole value chain from the development of microprocessor components and manufacturing to distribution, diagnostic, and counseling. This system is known as a Big Six or Big Five. The industry changed a lot, but the basic product concept of a professionally fitted device stayed the same in the last 20 years. During those 20 years, technology in general made huge advances. In 1997, a mobile phone was still connected to an analog network to enable conversation between two users. Today, the name telephone is barely justified when we are talking about a smartphone computer that is only an interface to a parallel universe that contains information, entertainment, work, social interactions, and so on. There are opinions that the hearing aid product has not yet benefited from this technological development. In particular, the known shortcomings of availability, affordability, acceptability are improving at a very, very slow pace. Coming back to the value chain of the hearing aid and the cost that is assigned to distribution and fitting, the question was there if the distribution can be optimized using technology. That means if fitting and diagnostic by a professional audiologist can, for some degrees of hearing loss, be replaced by technology. Reducing price and resolving some of the shortcomings could even be done simultaneously. This was the rationale behind the move of the US regulation agency FDA to introduce an OTC category of hearing aids. This prompted a discussion that is still alive today. In the next few slides, we will dive into more technological detail. So let us start. Developing of an OTC device is very often constrained by limited cost. But if you want to make a cheap device, it doesn't have to look cheap. And the industrial design is the wrong place to save your money. At the same time, industrial design is a very convenient way to make a distinction. So hire a professional industrial designer and make your device look as good as some of the best devices in the world, as this one depicted here. Very beautiful design from Scandinavia. The OTC category is placed in the borderland in between hearing aids and consumer electronics from the hardware point of view. So on one side, we have a classical hearing aid DSP system, as depicted here and made by company ON Semi, and Bluetooth system on chip, as this one depicted here from Qualcomm. It is important to see that parameters from one space, for example consumer electronics, are not the same as parameters from the hearing aid space. I think here about the audio quality, battery consumption, connectivity, and so on. So be very careful when you are choosing the hardware for your hearing aid product. The same is true for the software. The most important features of the hearing aids are implemented in software, and they must be derived from the use case. Signal processing is in the core of the firmware. Bluetooth system on chip are still not equipped with appropriate audiology software and compete instead with voice control, entertainment software, and fitness features, but this cannot replace the basic audiologic signal processing. On the other side, pre-configured hybrids from the hearing aid space have become very generic and drive too many products at the same time. It is difficult to differentiate when using some of those devices. It is very important to understand what kind of signal processing you need, what is your use case, and then to decide what software you want to use and if you want to make it yourself or to buy it. In the core of every hearing aid, there is a kind of a dynamic range modification. There is a mapping of input dynamic range to the output dynamic range, mapping of the whole world of sounds into a residual hearing. This is usually traditionally being done by wide dynamic range compression, which is actually a linear translation of one space into another space. But this was not always very good, because for some signals this rigid translation resulted in a loss of some features that are very crucial. For example, speech can lose the fine structures that are crucial for intelligibility and understanding. So in the newer time, a special signal-oriented amplification scheme were introduced. It is also interesting that a part of the VDRC, it's not in the hearing aid, but resides in the service, which is outside of the hearing aid. So many ways of precision fitting have been introduced in the last time, but no big change. Everything is still as it was 25 years ago. So I believe in this area there is going to be many innovation in the next decade. Changing dynamic range can be one way of improving the benefit of a hearing aid. But actually, hearing aid should mean that the user hears better, and changing a dynamic range is not the only way of doing this. Most of the problems of a hearing aid use are located in noisy situations. So if we use advanced denoising techniques as those driven by artificial intelligence, they're going to be an increase in signal-to-noise ratio that will improve the hearing even if there is no perfect fitting and if there is no perfect matching of the dynamic range. We also have to know that for different patients and different situations, there are going to be different products. So if someone has a very severe hearing loss, it is likely that matching of dynamic range will be very, very important. However, if someone has a problem with hearing only in noisy situation, then increasing signal-to-noise ratio might be a better solution. Another question is the comfort of the device. Using an electronic device on the ear introduces some comfort issues. So we need to provide enough comfort, for example, in mitigating the feedback of the device or mitigating the artifacts that are produced by signal processing. Talking about comfort, it is important to know that there can be a different interpretation of what comfort is. In my company, we have benchmarked many commercial products and have noticed a difference in their philosophies, a difference in how they interpret the comfort. Some companies want to be very technical, which means that every algorithm has to have maximal effect. The other companies, however, want to hide the technical effects and want to retain the naturalness of the sound. However, this is a trade-off between effect of the algorithm and naturalness of the sound. I have found in arXiv a comparison between two devices. One is by Signia, the other one by Phonak. And those devices represent very much the philosophies that are kept by those manufacturers. An algorithm for removal of impulse noise was assessed, and the impulse sound was noisy with the dish noises. The product A, the Signia product, was very technical, was reducing very effectively every impulse sound. But the remaining signal was very, very different in the character. The other product, made by Phonak, was very subtle, so the effect of the algorithm was minimal, but the sound was more natural after that. However, the impulse noise was still to be heard. So it is very important to know what comfort philosophy you want to follow when designing your device. Do you want to be a very technical device, or do you want to be a very natural device? It is enough that you know what is your problem and that you know what are you doing. Similar is true for the complete audiology concept and usability of the device. You have to do it top-down. That means first to know what the complete design should look like and then to design the parts of it. First, you have to answer the question, what is hearing loss? Is the hearing loss understanding less words of 100, or the hearing loss is a change in the audiogram? This is not always clear. Another important concept of the hearing aid is the user interface. And user interface, it's not only a volume control or the app, it is the whole concept of the device. The device should in general be appealing to the user, and the user will need to develop a kind of ownership of the device. And only in doing so, the user will be able to make a process of improving his hearing and perception using this device. In the process of developing of a hearing aid, it is very important not to forget the core purpose of a product. Here I have another story that might be used as an analogy. A few years ago, I passed a so-called €1 shop. There is a shop which sells things that are priced by €1 or $1 if you want, and saw a product in one of the bins. You probably know this product. It is an angle which is used for making angles for measuring wood or similar materials. And there are many features that are visible in this product. For example, you can see this hole, which is very useful if you want to hang this product in your garage. Or you can see the measure in centimeters on both sides. You can also see that the yellow color is very visible, so you can see this product even if you lose it somewhere in the garden. And also there is this black part which clearly distinguishes the yellow part and the black part. The black part is made of aluminum, so for this part there is no fear of corrosion. So I was very happy about this product, and soon after that I tried to build a cabinet made of wood and used it for that. But after cutting the wood, my cabinet would not fit together. So in the process I saw that the reason for that was that this beautiful product didn't have a right angle. So the angle was not 90 degrees, it was 91 degrees. So someone made the product which is at the first sight very good, but it's missing only the single feature, and that was the main purpose of the product. So to extend this analogy to a hearing aid space, we see that many hearing aids are introducing a new features like waterproof, like different colors, like connectivity for a telephone, and so on. But the main purpose of hearing more words of 100, it's not there, it's neglected. The fitting of a product, it's not precise, and so on and so on. It is important never to forget the main purpose of your product. So let us now go more into the real world and see how this OTC category is developing. We already see the first self-fitting hearing aids coming to the market, And we see that there is still not clear distinction between OTC, DTC, or consumer electronics. OTC should be the future category of over-the-counter sold hearing aids. DTC are the hearing aids that are sold directly to consumer, but maybe they need some kind of in-house fitting. And consumer electronics is everything else. So any hearing device which is not medical device. You can say that Apple's AirPods Pro is a consumer electronics made hearing aid. Since in every of those devices the involvement of the professional, of the audiologist is excluded, the self-fitting of those devices will be a crucial distinction point. Up to now, the self-fitting is reduced in order to mimic the process which is done usually by the audiologist, and as some kind of do-it-yourself routine, it's made to replace this part. But I believe that self-fitting will be a substantial innovation that will actually decide about the future of those devices. We can talk about some devices from the market, and maybe I will leave this part for the discussion after this presentation. So what does it mean that I expect self-fitting to be the next substantial innovation in the hearing aids? I believe that there is a great future in fitting by perception instead of fitting by prescription. So fitting by prescription is the actual combination of the diagnostics using the audiograms, and fitting by perception would be fitting by introducing the response from the user about his feeling of perception. There are many cases that support this concept. For example, there are non-linearities in the hearing loss that are very difficult to explain. When we are using prescription and are doing the mapping of the input dynamic range to the output dynamic range, not many of those non-linearities are concerned. So we are missing something, and we are assuming that we can approximately fit by ignoring those non-linearities. Fitting by perception doesn't need to know about the diagnostics. It only needs to know about the perception. So in the perception, all non-linearities are induced, are in the equation already. However, the concept of perception fitting, it's not new. Paired comparisons were actually the very first way of fitting hearing aids. Fitting hearing aids comprised of comparing one to another hearing aid. Only recently, machine learning was introduced to accelerate and to make paired comparisons better. And when we are talking about self-fitting hearing aids, one important side of it is the user interface. So if the user needs to perform the self-fitting, it needs an interface which will be addressing him and which will describe the world that he understands. So there are two user interfaces that are addressing the same feature, which is a paired comparison machine learning process. On the left-hand side, you will see an interface which is very user-oriented. It said select the person with a preferred voice. The user only needs to hear the voice and to decide which one he likes better. On the right-hand side, you see a device which is actually describing the algorithm behind it. It is expert-oriented and it's made according to the algorithm, not according to the user's understanding of the hearing problem. So When you are designing a user interface for a self-fitting hearing aid, you need to think about the user, not about the algorithm. It is hard to know what will become of the hearing aid OTC category. I can predict that there are three futures for this category. One is that the category will become nothing, that the description will be changed until the category will become obsolete. The other future is that the OTC category will replace the budget hearing aids. However, this is very sad future because it means that it will not have any substantial innovation and will replace only by lowering the price. And the third future is possible in case of the happening of the substantial innovation. Then the OTC category, which is coming from below, might mean the rejuvenation of the whole hearing aid space. This is something that I would really like to see happening in the next 10 years. But it is hard to say if innovation will also be a success. The innovation is necessary for a real success of the device, but is not sufficient. It needs to follow the right timing, and it needs a huge backing of financial and marketing resources. Talking about this, I want to remember a device, a very beautiful device that was introduced in the year 2005 and which resembled all the hearables, even the Apple AirPods Pro that will come many years after that. The device was very innovative, made by Danish manufacturer Microsound. The name of the device was Pilot, and you can see the picture of it here. But there was no success for the Pilot, and what we saw then as a future 20 years ago, it didn't happen. I even think that today this device would have more success than back then. In this sense, I wish a lot of success, and I'm curious what the products of the future will bring to us. And I will be now open for the discussion.